Hey everybody, Mrs. Logus again. I'm going to take you through the second page of the Chapter 10 segments review. Let's start here with number 5. For both problems below, round to the nearest hundredth when necessary. Okay, so my goal is to solve for x for part A. So the key to this problem is similar to the previous page. We had right angles that are assumed in some situations. We are given point of tangency. We can assume a right angle. Another situation that we can assume a right angle is there is when you have a radius and a chord. A radius, let me make sure that looks like the word radius. Oops. A radius is always perpendicular to a chord. Not only if a radius is perpendicular to a chord, something that also that we know is that the chord is bisected. So what we can say is that this right here, from here to here, this segment is my chord. When this radius intersects it, it splits this into two equal pieces, which means if this is 14, this is 14 as well. And so what we've created is a little right triangle where we have this side is 14 and this side is 15.6. So the theme of these first couple of pages is the Pythagorean theorem, because my goal is to find this side of the triangle. So I can apply Pythagoras. A squared plus b squared equals the longest side squared. If I simplify that, that's x squared plus 196 equals 243.36. If I subtract over the 196, I get x squared equals 47.36. Take the square root of both sides. X would be equal to 6.88. Similar idea to the next problem, that we have this segment, which is from starting at the center, and if I kept drawing it, it would go all the way here. So we have a radius again being perpendicular to a chord, which means that the chord is again bisected. That is a nice theorem to know. So we have this right angle here. So chord AB is chopped in half. So we don't know what this is, so I'll call it x. But if this is x, I know that this is x as well. So if I draw my little right triangle, or at least one of them, here's what I know. I know that the side across from the right angle, or the hypotenuse, is 11.5. And I know that the height here is 6.5, and I'm trying to find this. So Pythagorean theorem again comes to the rescue. X squared plus 6.5 squared equals 11.5 squared, which would be x squared plus 42.25 equals 132.25. I did these calculations earlier. So if I subtract over the 42.25, I get x squared equals 90. Square root. You could leave your answer one of two ways. If you kept it as a decimal and just plugged it in, you would get 9.49 as your answer. Now, actually, that isn't the answer yet. That gets 9.49 here, but the goal of this problem is to find the length of AB, or the length of the chord, which means that this is also 9.49. So the answer in decimal form would be 18.98 if I did in decimal form. Now, if you're interested, if you got to this point and remembered that you could write 90 as root 9 and root 10, that means that each of these would be 3 root 10 if you kept your answer exact, which means that the whole chord from here to here, you could also write as 6 root 10 if you'd prefer. So you could also say that AB is 6 root 10 if you want to keep your answer exact. Either is fine. Okay, so on this page we have 2 more problems, and these are word problems of which the picture is very helpful. Now before we start both of these, something that I'm going to write for both problems, your goal for these problems is to draw a right triangle somehow, because if you have a right triangle, then you can use Pythagorean theorem. So for both of these problems, I'm going to write that the goal is to eventually draw a right triangle somehow. So let's draw and see. Number 6, a chord of a circle is 48 inches long. Okay, so I'm going to draw a circle, And I'm going to draw a chord, so a segment from one side to the other, and it does not necessarily go through the center, so I want to make sure to draw it so it looks like it is not. A chord of a circle is 48 inches long, and it's 10 inches from the center of the circle. So I'm going to draw a dot in the center. What I view it is, I'm going to draw that segment there. This problem says that this little length is 10. And just like the previous problems, as soon as I have a radius and a chord intersecting, they intersect at a right angle and the chord is bisected. So if the chord is 48 inches long, that means that each of these pieces must be 24 units. The goal of this problem is to find the length of the radius. Now, a radius can be drawn anywhere in the circle. So I could draw a radius from here to here, but that is not helpful. That does not help me get a right triangle. That does not help me actually find what it is. So I'm going to undo that. What is helpful is if I draw a radius from here to here, from the center to the side, there I get a right triangle, and here I get a right triangle also. My goal is to find that length. Here's what I have now. I have a right triangle where I have the height of 10 and the base is 24, and my goal is to find my radius. So for the manyth time on this review, Pythagorean theorem again comes into play. 10 squared plus 24 squared equals r squared. 100 plus 576 equals r squared. So that's 676 equals r squared, square root, square root. This works out for us. The answer is 26. Because the problem had inches the entire time, I'm going to put inches on my answer. So notice that how I drew this, that I drew my chord, but my goal was to draw a right triangle so I can use Pythagorean theorem and use knowledge that we remember from earlier in the class. Number 7. The diameter of a circle is 26 centimeters long. So I'm going to draw a circle, and a chord is 24 inches long. We have a chord and we have a diameter. The goal is to find the distance from the center of the circle to the chord. Okay, so I'm going to have a center in the problem. I'll draw the chord in the same place. My goal is to find this distance from center to chord, so I'm going to label that x. That at least helps me kind of know. Now again, what is very tempting is as soon as you see the word diameter, it's tempting to just draw a line like this directly across and say that that length is 26. While that is true, that does not help me with my goal of drawing a right triangle. Here is what can be more helpful. Okay, what I can do is remember that if the diameter is 26 units, the radius is half of the diameter. So my radius has to be 13 units. And just like the previous problem, how I drew the radius like this to actually form a triangle, what if I drew my radii like this and said they were both 13 units? That helps me a lot because now that I have this picture drawn, I have a radius and a chord intersecting. So I have right angles and a bisected chord. The diameter is 26, so we made these both 13, and a chord is 24 inches long. So it means that each of these have to be 12 because the entire thing is 24. So now, if it helps, we have a little right triangle again. Hypotenuse is 13, base is 12, and we're trying to find x. So again, Pythagorean theorem. X squared plus 12 squared equals 13 squared. X squared plus 144 equals 169. X squared, if subtracted over, is equal to 25. Square root, x equals 5. Now, to be consistent, I'm going to go ahead and make sure that this has centimeters on it because the rest of this word problem had, both of these should say centimeters. This one says inches. That doesn't seem appropriate. Yeah, both of these are inches. This should say centimeters as well. So my answer should be in centimeters. So you might notice on this page especially, the theme is the Pythagorean theorem. The theme is to get a right triangle so that you can work with it. And the theme on the first page was also right angles and knowing that a radius can repeat and be drawn in multiple places. So that's the key for a lot of the beginning of this packet. I hope this was helpful. Feel free to rewatch and use to study. All right, thank you. Good luck.